Have you ever stood in a snow-covered field, looked around, and wondered, how can something that comes from water, which is completely clear, turn the world so bright white? It's one of those everyday mysteries that most of us accept without question. We grow up seeing snow as white. It covers rooftops, trees, and entire landscapes in a clean, glowing blanket. It reflects sunlight so strongly it can be blinding. But think about it. Snow is just frozen water. Water has no color. So how does it become white? To understand this, let's break it down into smaller parts. First, we have to look at what water really is and how we perceive color. Then we'll dive into what snow is made of, because snow isn't just cold water. There's more to the story, and it's hidden in the tiny details. Let's start with water. Liquid water is colorless. You can pour it into a glass, hold it up, and see right through it. Technically speaking, pure water has a very faint blue tint when observed in large volumes, like in oceans or deep lakes. But in small amounts, like in a cup or a single drop, it's completely transparent to our eyes. Light passes through it without much interference. Ice, which is just frozen water, can also be clear or slightly translucent depending on how it forms. If it freezes slowly, the molecules line up nicely, and you get a clear ice cube. But if it freezes quickly or has air trapped inside, it becomes cloudy. Still, even cloudy ice doesn't look white, it just looks a little foggy. But snow? Snow isn't just ice, it's something different. Snow forms when water vapor in the air condenses directly into ice, bypassing the liquid stage. This process creates ice crystals, what we call snowflakes. And here's the interesting part. Snowflakes have a complex, intricate structure. They're made up of many tiny flat surfaces, ridges, and branches that scatter light in all directions. This scattering is the key. When light hits a single snowflake, it doesn't pass straight through like it would with a drop of water. Instead, it bounces off the many surfaces inside the crystal. Now imagine millions of these snowflakes packed together on the ground. Light enters the snow, hits a crystal, reflects, then hits another, reflects again, and continues bouncing around. This effect is known as diffuse reflection. It's the same reason powdered sugar or crushed glass appears white. The tiny particles reflect light in all directions, and when all wavelengths of visible light are reflected and mixed together, our eyes perceive the color as white. So in simple terms, snow is white because of the way light interacts with the ice crystals. It's not that the snow contains any white pigment or color. It's all about physics, how the structure of snow affects the behavior of light. This is a great example of how structure changes perception. Take salt or sugar, for instance. A single grain might look clear or translucent, but pour a pile of it onto a table and it looks white. That's because light is being scattered by all those tiny crystals. Snow behaves in the same way. It's not about the material itself, it's about how light behaves when it hits that material in a certain form. Let's get a bit more technical, just for a moment. When light hits an object, three things can happen. It can be absorbed, transmitted, or reflected. If light is absorbed, the object looks dark. If it's transmitted, like through clear glass, it goes through. If it's reflected, it bounces off the surface. In snow, very little light is absorbed or transmitted. Almost all of it is reflected. And because the reflections happen in so many directions and from so many surfaces, the light gets scattered evenly, creating that familiar white appearance. Interestingly, not all snow looks exactly the same. Freshly fallen snow is usually the brightest because the crystals are still sharp and intact, which helps scatter light more effectively. Over time, as the snow gets packed down, melts, or partially refreezes, its reflective properties change. That's why old snow can start to look gray, slushy, or even dirty. There's another factor at play too: air. Snow has a lot of air trapped between its crystals. In fact, fresh snow can be up to 90 to 95% air. This air adds to the scattering effect. The boundaries between the air pockets and the ice surfaces enhance the bouncing of light. So, now you can see, snow isn't white because of some magical transformation.
It's white because millions of tiny, clear crystals reflect and scatter light in just the right way. Let's take a quick step back and ask, why do we even care about this? Well, it's a great reminder that the world around us is full of hidden science. Things that seem obvious, like the color of snow, are actually complex interactions between matter, light, and human perception. For example, think of clouds. They're made of tiny droplets of water or ice. Each droplet is transparent, yet clouds appear white or gray depending on how the light is scattered and absorbed. Or take milk. It's a white liquid because the fat and protein particles scatter light in much the same way snow does. Understanding how snow becomes white helps us understand broader principles of optics, physics, and nature. And that's valuable because these principles show up in everything from how we design solar panels to how we understand vision and photography. It's also just beautiful. Knowing that the color of snow comes from light bouncing between billions of crystals doesn't make it any less magical. If anything, it adds to the wonder. Nature didn't need a paintbrush to cover the mountains in white. It just needed ice, air, and a little light. So next time you see snow, you'll know you're not just seeing frozen water. You're seeing a massive natural light display created by structure and physics. The snow is white because it reflects all colors equally, and our eyes perceive that as white. And here's one last interesting fact. If you were to take a single snowflake and look at it under a microscope, you'd see the famous six-sided symmetry. Snowflakes form this way due to the molecular structure of water. Each molecule of water has a bent shape, which leads to hexagonal patterns when they freeze. That's why most snowflakes look like stars with 6 points. But no two snowflakes are exactly alike, because the conditions in the atmosphere, temperature, humidity, wind, are constantly changing. Each flake grows in a unique way. That's why people say every snowflake is different. Isn't it amazing how something so small, so common, can hide such incredible science? Now that you know the secret behind snow's white color, what other everyday mystery do you want us to uncover next? Watch the full video to see animations, examples, and an easy breakdown of everything we just talked about. You don't need to be a science expert. We'll walk you through it, step by step. If you learned something today, or if this sparked a sense of wonder in you, make sure to like, share, and subscribe to Wiseuse. We've got more fascinating facts waiting to be discovered. What everyday thing have you always wondered about? Let us know in the comments.